Well,
Yeah.
this is recording right now for you. Do you see this problem right here? A good thing to do is when you have the position 1, 2, 3, and 4, and then we see the sequence, correct?
Yes.
Right? I'm going to erase this. We have the position, and we have the sequence. You watching?
Yes.
Now the sequence grows by what?
The sequence grows by 3.
3. If the sequence grows by 3, that means the rule, right, the expression will have 3 times n, correct?
Yes.
3 times whatever is in the position. So n is really...
N is the position, basically.
n is the position. So I'm going to put
So
n.
it's-
n is the position, right?
So it's basically, in this example, it's 3 times 1, which is 3, plus 1.
Oh, yeah.
And for the next one, it's
And you got it.
6 plus 1, since 2 times 3 is 6.
Good. Now, one thing you can do if that's hard to remember, all right, is simply take the sequence and go down, take the position,
Yeah.
correct, and add 0.
Okay.
Adding 0 right here, I'm going to draw it in black, all right? Now, and 0 is easy because when the position is 0,
Yes.
then we simply look at, okay, 3 times, it's going up by 3. It's going up by 3. Therefore, this is going to go down by 3. So what is 4 minus 3?
4 minus 3 is 1.
1. So
So we can find the
sequence is
position
gonna be
back
1, right?
as well.
if the position is 0, it's really easy because what is
0 plus 3 is 3.
3 times 0?
3 times 0 is 0.
And how do we go from 0 to 1?
Because you add 1.
There you
Even though the position doesn't times anything, you still always add 1.
Correct, because so that's sometimes an easy way to do it. That makes sense? What you did is actually good. You realize, I think the first thing to do is see what are those numbers growing by? It's 4, 7, 10, and 13, correct?
Yes.
They're growing by 3, right? So because these are growing by 3, we know that we're going to multiply the position by 3.
Yeah.
So we know that 3n is going to be part of the rule.
Yeah.
And then what you did is like, okay, well, if that's part of the rule, 3 times 1 is what?
3 times 1 is 3.
Okay, so if 3 times 1 is 3, how do we go to 4? Right here. We have to add 1, right?
Yes.
So that's really how you found the rule.
Yeah.
Sometimes it's a little easy, so then you can bring the position to 0 and then see what, and work backwards. Make sense?
Yeah. Position to term rule. That is
So
the
just
position
have
to term rule.
the term to term,
Term to term.
term to term rule is,
Basically, sequence is term. Basically.
yeah.
So
The term to
I
term
already
rule is,
know the position.
yeah, what is it? It start with what?
It starts with 4 and add 2, but no, it doesn't. It does start with 4 and add 2.
Correct. Right,
Really?
and now we have 1, 2, 3, 4, 5, 6, and then we added 2. Okay, that's the term to term rule, right?
Huh?
Make sense? Now, because it goes from term to
But
term.
my dad said I was almost correct. Okay.
So let's look at now the position to term rule. So you got the term to term rule, right? Term 1 has 4.
Yeah.
Term 2, well, you add 2 to it, right?
Yeah.
So each time
But we're
so you
looking
start
at
with 4 and you
the
add
term
2.
to term rule.
That is the term to term rule.
Yeah. So.
Now we're looking at the position to term rule. The position to term rule means, let's say
It's
what-
1 times 4 and then add 2 each time. So position 0 would be 4. Position 1. Oh, no. I have a
Oh, let's do that.
I do have a better idea. It's position times 2 and add 4.
Okay, so position 0 will have how many squares?
2.
Okay. Now my other question is, how is this growing?
It's growing by 2 each
It's
time.
growing by 2, right?
But can I explain a reason
Yeah.
behind it?
Okay, almost. What do you think the position to term rule is?
2 2n plus 4.
Okay. 2n is correct. Why is it 2n? Why is it 2n?
2n.
Because it's growing by what?
Because it's growing by 2 each
by
time.
2 each. However, how many does figure 0 have?
That's not.
How many tiles does figure 0
2.
have? 2. Look at this. Now, let's look at this. If we're looking at position number 1.
Okay, fair enough.
One is.
So it's 4n plus 2.
2n plus 2.
Why 2n plus 2?
Because it's growing by?
2n. Oh, okay.
Growing by 2. Therefore, we have the 2. Yeah.
So,
And 0 starts
is
with...
the term-to-term rule correct? That's what I'm asking.
The term-to-term rule,
Which I wrote
you
here.
got correct. Start with 4 and add 2. The position term rule, which is this is called...
I see.
I know writing in red. This is a rule, right?
Yeah, my dad thought that this was, that this was the position term, whatever.
So for example, we have 2n plus 2. Let me erase this, and I'll show you why this is a position term rule. Let's just say we have position, I'll write in black, we have position 54. Now, obviously, we're not going to write all these tiles, right? So we need to know, well, if I sketch this out, okay, we're just going to go like this. How many tiles would position 54 have? That's a tough question, correct?
Yeah.
You could not find that answer with term to term, which is start with 4 and add 2. You could, but you would have to do that 54 times. That's a lot of work. So we do it, rather than doing the term to term rule, that's when the position to term rule, which is a rule, kicks in. And the rule here is, do you remember what the rule is?
It's 2n plus 2.
Woo, nice. 2n plus 2.
Yeah.
Now you can solve this. If the position is 54, what do we do?
Right.
So, say that again so we can hear.
So,
Position is 54, what do we do?
you replace n by 54.
Perfect.
So basically it's 2 bracket 54. Like this. Plus 2. I can't write as well as you
Perfect.
do.
We're not going to calculate that, but that's exactly. So that is the position.
It is easy. I can calculate it. It's 108.
Nice, we're out. I don't know if you can read my writing, but so this question number 4D on the test is how many blocks are needed for the 18th shape? Got it? And here's the rule that you discovered. What do we do? Okay, you're on. It's recording.
Okay. So, it would be 2 brackets 18, close bracket, plus 2. So we multiply 2 times 18, which is 36. 38, because we add 2. Sorry.
That's correct. You are correct. Bada boom, bada bing. Okay, you ready, Royal? I actually changed the number a little bit. Can you read this to me?
Yes. Sequence has position to term rule. Multiply by 4 and then add 3.
So I want you to write down the first 4 terms
Yep.
of the sequence. What are we going to do?
Terms. Multiply by 4. So, 1 times 4 equals 4 plus 3 equals 7. Okay? So you can just replicate this process for the rest. So 2 times 4 equals 8. 8 plus 3, equals 12. I almost made a mistake here. 11.
All right, we're going to just stop. Okay, Aurel. So I'm going to just ask you
Yeah?
a question. I think you made a mistake here.
No.
No, you didn't make a mistake here. You got it right. I think you did. Looks like you did. Yeah, you got it right. So term 1. Now, I don't want you, I'm going to write this out for you. Term 1.
Wait,
Okay?
which one are we
You got
doing?
this right. Term 1.
Are you doing this
You
one?
got, yeah, you got 7.
It's 2. It's 2, which is the...
Term 2, you got 11, correct? Which is correct. Correct? Because the rule is 4n plus 3.
But it's... So...
Yes, I added a 3 to this just so it's a little different than the actual test. In the test, it was add 2. But this, I put add 3.
Okay.
So this is our rule, 4n plus 3, right? So you did, yeah. You said, oh yeah, 4 times 1 is 4, plus 3 is 7. Excellent. 4 times 2 is 8, plus 3 is 11. I want you to look at this. You ready? I want you to see if, without calculating, you can do the rest.
Yep.
Okay? Without calculating, can you do the rest? And I'm just going to add, yeah, can you fill out the rest? 3, 4, and 5 without doing any calculation?
3, 4, and 5?
Mm-hmm. Try and do the rest.
No problem. So, 3, 4, 12. Oh, I almost wrote down. 12 plus 3, 15. Right? 4 times
No.
3. Why not?
Now, I want you to do it without calculating.
But it is, though. It is correct.
4 times 3 is... Oh, you're right. My bad. Excellent. Now,
Mr. Thompson.
however, you are calculating.
Yeah.
You are calculating, which is fine.
But
I want you to do this without...
Oh, I see what you're saying. I'm sorry. I misinterpreted.
Every time it goes up by what?
By 3.
So, do it without calculating.
Easy. 18 and 21.
Perfect. Now, that was beautiful. And once you get the first
But
couple terms,
I
you can
got
do
it
the
right
rest.
here.
You ready? We'll summarize here.
Yeah.
Key is term to term and position to term. So term to term and position to term. Got it?
Yeah.
Term to term is literally what it is, term to term. So we have here term 1, 2, 3, 4. I'm going to write these numbers down, yeah?
Yep.
Let's just say we start off with, I'm going to put a 0 here. 0, so this is 0. Let's say 2, 4. Okay, see this, Aurel?
Yes.
Here's a sequence. Got it?
Yes.
Here is n. Okay? Well, you're getting Nancy, yeah?
Huh?
Term to term.
I'm getting what?
Term to term
You're
is
getting what?
Nancy.
Which means what?
Restless. We're almost
Yeah.
done. Term
No,
to term.
I'm getting restless because I'm excited about
Oh, excellent.
the prospects of the future
Okay.
in mathematics.
So term to term is you start. What's the term to term? You start with what? Actually, I'm going to get rid of this. You start with what?
We start with 4.
And add what?
And since add 2.
Perfect.
Ah.
Start with 4. Add 2. Start with 4. Add 2. Got it?
Yep.
Now the position to term rule is a little different. What's the position to term rule? We have 1, 2, 3, 4.
For example, for position to term, I could easily, basically, what I can get in here, it's 1 time, it's x or n or whatever variable you prefer to use.
We'll use n.
Let's use n. So it's n. Are you still recording? Okay. It's yeah, I can see. It's n times 3 plus 1. It goes by 2, so it's n times 2.
So n times 2, and we're going to put the 2 in front of the n.
And add 2. So it's 2n plus 2.
Bada boom, bada bing. If it's 2n plus 2, now what would position 37 be?
Position 37. Easy. Can I have a pen, please? Thanks. Let me write here. So it would be, as I said before, I don't need a pen for this, I can do it. You replace the n by 37?
37.
By 37, so we cross off the n and make 37. And so 2 times 37 is 74.
Okay. And then, you forgot the what?
And add 2 equals 76.
Perfect. It would be 76. Awesome.